All right, good morning. Today we're going to be looking in math at bar graphs. And you're going to be working on these pages in your notes. So starting with this one with the mouse on the top. Maybe that's a rat. I don't know. It says page 140, and you're just going to be working on 140, 141, and then you have another page that will have 142 and 143 on it. So make sure you have the right pages for today. All right, when we're looking at bar graphs, we can look at bar graphs and break them down into 4 parts. So we have a vertical and horizontal axis. And what that fancy word axis means is it just means we have a line that goes up and down. That's our vertical axis. And we have a line that goes side to side. That's our horizontal axis. And that's where we set up our information for our bar graph. So you can have a scale on your bar graph, and that's what keeps track of the numbers part. So your scale can be on the vertical axis like it is in this first graph, favorite pets. Your scale could also be on the horizontal axis. On the second graph, students in a school. It's your choice. You will find that most bar graphs have the scale on the vertical, the up and down axis. Remember that your numbers line up with the lines, not the spaces on a graph. That should help you. And the 0 always starts in the corner. Some people are tempted to put that 0 on the first line out of the corner. Make sure your 0 is right in that corner. Right. And then we also want to spread our labels, whatever we are graphing. So here we're graphing pets. We've got cats, dogs, and hamsters. Oh, maybe it's a picture of a hamster. We want to spread them out on whatever space we have in our graph. We don't want to jam our labels right beside each other. We like to spread them out because it makes it easier to see. And then, of course, we have data. And the data in a bar graph is shown using bars. So hopefully your pages, you can clearly see the bars used to show these graphs. They should be shaded in kind of gray, a little tricky to see on my screen. So let's get into the work. To answer question 1, we're going to look at this graph here, the eye color of the students in Mrs. Goudreau's class. And we're just going to try to read this graph and answer some simple questions about it. So how many students in Mrs. Goudreau's class have green eyes? So we're going to look at green, and we are going to say, okay, looks like 8, because the top of the green bar lines up with the 8 line. So we have 8 students. Oh, for some reason I'm drawing a shape. There we go. Oh my goodness. What has happened? We're now having technical difficulties. There we go. Let's see if I can make an 8. Nice. And how many students have brown eyes? Well, we look at that bar and it goes all the way up to the 12. Okay. So it's pretty straightforward, these questions. I like questions like this where it makes you look at the graph. Here it says altogether, how many students are there in Ms. Goudreau's class? And to figure that out, you would take a look and see, okay, well, 12 students have brown eyes. We've got 8 students with green eyes. We've got 4 students with blue eyes, hazel eyes. Ooh, I hope you can read that better than I can, because I can't really read that on my printout. It looks like it goes all the way to the top, so I'm just going to pretend it does. So we've got 14 students. Okay, so if you know how many students have each different color of eyes, you should be able to figure out how many students are in the class by adding them all together. Okay? That's a question you'll often run into when you're working with graphs. On the second page, we're looking at a tally survey chart that Anita did. So these are the different flowers in her school's front garden. We have 12 marigolds. This is how tallies work. You've got 1, 2, 3, 4, and 5. So you can easily count by fives. 5, 10, 11, 12. 4 sunflowers. Oh, I think the first thing you need to do is complete the count on her tally chart, which is what I'm kind of doing for you. So we've got 12 and we've got 4, and you can do the last 2. Here it says use Anita's tally chart to complete the graph. So give your graph a title, and it's always a good idea if you're given a chart and information. So we've got flowers in the school's front garden. That might be a good title. Something to do with that. And they've set it all up nicely for us. So marigold, we knew there were 12 marigolds, I believe. So I'm going to use a ruler. I can't use a ruler, so what I'm going to do is use a rectangle shape. And I'm going to make a bar that starts at 0 and stops at the 12. Graphs always look a lot nicer if they are colored, whether you're using different colors for your bars or the same color. Just always stands out and looks nice. What are 2 conclusions that Anita can draw from her data? That conclusions word, that means what are two things you can tell me about the flowers in the garden based on looking at the graph? So come up with 2 things. Okay, moving on to the next page, 142. This is all about choosing a scale for a bar graph, and this is where things can get tricky. So in these first couple questions, we're looking at the scales in the bar graphs, and we're just answering these questions. So what are we counting by? Well, in the first one, we're going up by 2, 4, 6, 8, 10, 12. We're going up by 2. Count by 2. That's my messy 2. And stop at 12. So that's all I want you to do for those first questions. Okay, the next one says, favorite sports of Mrs. B's grade 4 class. So we have a bar graph, we have a tally chart, and we've got some questions here. How does the graph make it look like twice as many students chose baseball over soccer? Hint, look at the height of each bar. So here's baseball, here's soccer. Do your best to answer that question. Here it says, what's wrong with the scale? So this graph has something wrong with the scale, and it's affecting how the data looks, because baseball, we had 8 students enjoying baseball and 6 students enjoying soccer. But if you look at the graph, it looks like twice as many people like baseball. So that's weird. What's going on in the scale that's making our graph results look weird? Okay, that's what you're looking at for question B. Now question C says redraw the bar graph with the correct scale. You could do that on a plain piece of paper. Another thing that you could do is just on this side of the scale. Let me erase that circle I made. I can, good. You could make your own scale. So you could, we're going to have 4 spots. So instead of going 1, 6, 7, 8, remember we're starting at 0 down here. I wonder what we could count by and then stop at so that we include all the data. Down at the bottom of the page, it says choose a scale that doesn't have too many or too few markings and draw a bar graph for each set. So this one, you will need a separate piece of paper to draw the bar graphs. If you don't have a separate piece of paper, I don't know, I don't think that's too much to ask. Find a separate piece of paper and create these bar graphs. I guess if not, then write down what you think the scale should be. So you could do what we did in that first question, where you tell me what we're counting by and what you would stop at if you were creating this bar graph. So that's for A and B. Determine the values of the other bars on the graph. Well, this is nice. This is interesting. I'll do the first one, and then you can try the next two. So we've got bars, but we have no scale. But we do have an amount for one of our bars. So this bar that goes up 2 squares is 10. And if I think about what would I count by to get 10 after my second count, or you might think, what's 10 divided by 2? We'd be going up, this graph looks like it's counted by 5s. So you might have a 5 there, 10 there, 15 here, 20 here. So it looks like B would be 20. I could just write that above that bar. And A is going to give me a problem because A looks like it's in between 10 and 15. It looks like, well, I know the numbers in between 10 and 15, kind of in the middle of 10 and 15 are 12 and 13. So if I want it to be exactly in the middle, which is where it looks, I could say 12.5, or I could just say 12 or 13. But why don't I do that? I'll say 12, and that would be fine. If you said 13, that would be fine as well. If you said 12.5, it would also be fine. All right, the last page of your work here is working on double bar graphs, and double bar graphs are interesting. If you haven't worked with them before, I just want you to try this page. It can compare 2 categories, and like a bar graph, it'll have all those same things, but you're going to break your categories down into something else. So here we have number of students, we have favorite type of book, and we have a chart for this. So we have novels, comic books, and fact books. But instead of just making bars for novels, comics, and facts, the teacher or whoever made this graph broke it down even more into girls and boys. So we now know that the girls' favorite books are novels, and the boys' favorite books are actually facts. So when you're doing a double bar graph, you need to have a key that tells you which bar belongs to which category. So you need to label your key in this question. So I'm going to say girls and boys. And then you need to choose a color. So girls, I'm going to choose green, and boys, I'm going to choose purple. And then you would color your graph, and you want to make sure you get the right data. So novel, 10 girls liked, good. So it looks like the first bar is going to be for girls. So you're going to color that in, and the second bar for each type of book is going to be the boys bar. And your double bar graph can look nice and sharp like that. Okay, then you're going to answer a couple questions. What's the most popular type of book among boys? Lots of questions that you can read through and answer. Down here it says, Keiuzo started drawing a double bar graph for the data below. She started with the summer data and drew her scale as shown. So she did her summer data going all the way up to 18, counting by 3s. How does her scale make sense? How does her scale make it hard to show the winter data? So you're going to have to look at this chart and answer the question. And the last one here says, what scale would you choose for the given data? So we have data that ranges from 2, and the highest number is 40. So that's really what you want to look at when you're choosing your scale. What's your smallest number? What's your biggest number? And here it's asking you, what would you count by? And where would you stop the scale? Okay. Hopefully that explanation helps you as you work through your math today. And I hope you enjoy working on graphs as much as I do, although it's going to be tough to beat me. All right, enjoy your math and have a great day.